Hello everyone. Welcome to Digital Technologies course for Ping Z1, and my name is Ashutosh Tiwari and I am going to discuss basic Python codes in Ping Z1 book. So in previous webinars you just learned about deep neural network and object recognition, face recognition, but today we are going to discuss other applications that can be developed in your Ping book. So, as it suggests, Ping board is an all programmable SOC or AP SOC, which can be used to design logical circuit without programming the PL side. So, it has a web server which is hosting the Jupyter notebook, and with that, it can be used for PS programming also. So, Ping Z1 has a 512 MB of DDR3 memory. Along with that, it has a gigabit Ethernet PI chip, so you can, which is used on the PS side. Ethernet is present on the PS side of your Ping Z1. Along with that, you have an HDMI source to sync port. You have a PDM to PWM audio pipeline interface with that. So it contains a dual core A9 processor. So we are going to see how you can implement other high bandwidth peripherals like a gigabit Ethernet, and through Ethernet how you can access the internet and use for other Python applications rather than low bandwidth peripheral. So let us start with the coding part. So the first application which we will discuss is about 3D planetary system. How you can implement a 3D planetary system in your Ping book. So we have given some constant. We have 60 seconds, 60 minutes and 24 hours as our 1 day simulation time which it will consider, and for 1 year of simulation time step it is going to simulate it for 1 year. The constant for this we have to find declared the initial position and velocity of your earth, and this is the given on the array format. Now with this we have declared we have found what is the acceleration and the distance and the acceleration. So based on that, we are going to plot it on your 3D plot. So this is something we are using it for sun. We are going to describe this as sun. We have given the name as sun for this, and this is for planetary orbits. So this is the difference. Now update the layout. Now we are trying to consider both x, y and z. So x, y and z is our yaw, pitch and roll. So this is our sun, and the planetary system is revolving on spherical. This is a sphere. So it is rotating around the sun continuously. So the first part. Now how you can implement the next phase. So we are using these bodies. This is for sun, this is for earth, moon, Mars and Jupiter. So all these bodies we are using it on this, we are passing in this, and now we are going to start our simulation to compute the gravitational forces for this. So this is where you are finding out the value of force, calculating the distance, and with velocity integration you are going to find out how the bodies are moving with respect to sun. Now along with this we are also calculating the kinetic and potential energy. This is the energy calculation. So kinetic and potential energies are used to find out the total energy, and based on that we are going to give or show you in animation how you can use it for Sun, Earth, Moon, Mars, and Jupiter. So this is the animation frame. This is the advanced 3D animation frame, and we have to see that we are using the X, Y, and Z. Whatever the X, Y, and Z titles we are showing, this is the X, Y, and Z for this. So this is the X, this is the Y, and this is the Z axis. So if I play, we are going to see the X, Y, and Z. So initially Y is incrementing, not incrementing, it's changing continuously. Then this is how you get the energy. What is the energy that has been used? How much energy has been used in this? So this is how you can find out the body planetary simulation. So this is just a simulation. So there are other ways to find out the real time. GPS is required to find out what is the real time. We can even find out that using extended Kalman filtering. Now, after this is finished, what happens if we are going from mode normal to mode chaos? What happens? How is AI is implemented? How is AI, what role AI is going to play if the mode is changed from normal to chaos? So we are going to run this, and going inside the code, we will see that we are again using some constant values, 60 into 60 into 12. Now, the bodily parameters what we have given for base solar system for Sun, Earth, Moon, Mars, and Jupiter is same as what we showed in here. This is the same. So both values are not changed. Now we have to figure out what happens when your mode is in the chaos part. This is the AI analyzed 3D planetary system for chaotic system behavior. So this is for Earth, for Moon, for Mars, and for Jupiter. So we have to find the orbitary part. So the Moon and Earth, they are not that different, but Mars is little bit distance is maintained between Earth and Mars. Whereas Jupiter, the distance is more. So even though the velocity is increased, the visualization has to be seen on real time. So now going back to how you can find out the real time GPS data. Suppose your ping board has an Ethernet. Yes. So this Ethernet can be used to find out the real time GPS location. So this the first algorithm what we will implement is called as extended Kalman filtering. So extended Kalman filtering is an algorithm. It is a very good what you can say, a very good way of writing this in Python. This is, even though it is just a simulation, we can find out how you can find the extended Kalman filtering. So this is used on all planetary systems. So in order to find the GPS data, what is the latitude and longitude of our current position. So what we have done is we have used this EKF and UKF, extended Kalman filtering. So this is used to find the real-time GPS. Yes. So this is just a simulation what you're seeing, but you can also find out the real-time GPS of your ping board. That is the point which I was trying to point. That even though you have this ping board, even though you have this internet connection, that internet connection can be used to find out the real-time GPS of your current location. So let us go to that. The simulation parameters, this is the true initial state. So EKF, extended Kalman filtering, initially it is 0. Now this is the noise and this is the process noise and measurement noise. How we are going to find out the Kalman filtering? So we have to use a Jacobian matrix for this fx. So dt is the change in the time what will come in this, and Jacobian hx. So the true measurement, this is the EKF updated value. So it is going to predict the EKF and prediction. This is the prediction formula. The Jacobian hx, Jacobian f. This is the array in which it is stored, and this can be is passing the x estimated value. The estimated value of xest is going inside, and with that you are going an update of EKF update, Jacobian h of x predicted value and estimated value. So with this we are going to figure out what is the true state. So x true, it is going to give you the true system is going to give you the true position. So this is where you have to figure out the Jacobian f x true value, whatever you will give this value, this x true value is going to be passed inside this the zeroth array value, and it's going to append and it is going to find out the true position, and the EKF estimate is the estimated value. So x estimated value is along with the prediction and the flattened surface. So this is the, I have used a MATLAB function plt.plot. So with this you are going to find out what is the true position and what is the extended Kalman filter estimated position value with the graph. So now how am I going to figure out this simulation time step? How am I going to figure out what is the GPS tracking? So the next point is the simulation time step. With this simulation time step, I'm going to find the EKF initial guess. Everything is initialized to 0. The process noise multiplied by 0.01. GPS measurement noise, the covariance value is given as P. Q is the covariance, and R is the noise covariance. Now the state transition function, we are going to pass the state transition function. So what is this x value? So as I explained before that we are using a Jacobian uh, measurement value. So for this the GPS, how we'll find the GPS of your ping Z1? So that is the main point, is how you are going to figure out how are you going to enable the GPS without using any additional modules. So this is the measurement function Jacobian of f. This is in an NP array. This is the Jacobian matrix and Jacobian of f. So we have to find the true path, GPS path and EKF path. So the EKF loop, what is happening in this is just the true position with the NP zeros value. The Q is the value of this, the process noise covariance. So process noise covariance along with the true position, the true position is the x true value, and with addition of this we are going to find out the true motion of your extended Kalman filter. Along with this, you are going to find the GPS measurement. We are going to find out the GPS measurement. So for GPS measurement, you have to take R as your next value. So R is your GPS measurement noise covariance. So R is used here for GPS measurement. H is the measurement function of GPS. So we are adding this and then we are trying to predict what is the Jacobian value, the prediction of your true measurement, the true motion and your GPS measurement. So the x predicted value is the x estimate value, and for the p prediction you have to use this formula. So once you keep on updating, this is the updated value Jacobian h, y, s and k. So the estimated value is the prediction value plus the k value, the p prediction and your y value. So these two values are going inside and you are adding it out. Then the s estimate is given that value. So the appended value, whatever you are trying to get in this is the true path for this. So you have to show it on array and you are going to show the GPS tracking using EKF. So now let us see the graph. So this is the true path. This is the EKF estimate. This is shown in a graph. If you are not understanding the formula, this can be an easy way to understand this. And this is the GPS prediction. So true path along with the GPS prediction and EKF estimated value. Based on that, you are going to understand how using Jacobian matrix you can implement extended Kalman filter in your ping Z1. So till now we have not understood, like we are not in a phase of understanding the GPS measurement because you don't know what is my GPS, what is my present latitude and longitude. Yes. So now the true location, I am using this function. So if I run this code, now let me run this. So before going in that part, let us see how this location part is used, the XEKF and UKF, extended Kalman filtering and unscented Kalman filtering. So this is the GPS point. Again we are using the same thing, but now we are using alpha, beta and lambda functions along with kappa, and this is where it is used to find out the WM and WC value. So this simulated noisy GPS, it is again we are coming to this was already used on our previous code, now we are using it again. So yes, this is the output EKF versus UKF. So the simulation noise step, we are first calculating the extended Kalman filter. We are calculating the extended Kalman filter. With extended Kalman filter, next we are going to the UKF. This is the UKF formula. Now I'm going to predict the mean value, the covariance value and measurement prediction. So this is the cross covariance formula, and with this you're getting the GPS points of EKF and UKF, and I'm just plotting this in this equation. So this is the EKF versus UKF. So EKF is in the orange line and UKF is in the green line. So this is the green line which I'm using, and this is the noisy GPS. This is the noisy GPS data. Now, till now, this is all just theory. Yes, so even though you may have understood something, if you may not have understood something, this is all just theoretical part, this Jacobian matrix, all this. But coming to the real time, once you come on the real time of Jacobian matrix used to understand or predict the GPS and extended Kalman filter and unscented Kalman filter, how are you going to figure out what is your real time GPS data? So, this is how I'm getting. I have the internet access with me. Yes, so what is happening in this is I am trying to use this based on my Ethernet IP address. As my Ethernet is getting a fixed internet, I'm using this website and I'm trying to find out what is my present latitude and longitude. So my latitude and longitude, whatever the data I'm receiving from this, I'm trying to display it on this. So this is the another part. Like I said, this is all just a theoretical formulas which you may not have understood, but this is where the main equation comes into the picture. How are you going to figure out the real time GPS? So we are trying to bypass the GPS of your ping Z1 book. So this latitude and longitude is the present GPS location of your digitode technologies. So this is what we have used in your Bengaluru location. So the present latitude and longitude has to be taken using this code only. So there are many other ways to find out the GPS, but as you have an internet connection with you, you have to try to, instead of using other GPS module to figure out the real-time GPS, you have to figure out by using this chunk of code. So that is how the Bangalore location we are using the true latitude and true longitude. This is the true location of your latitude and longitude. So based on this, you are getting this simulation output. So once my GPS data from internet, I'm getting the GPS latitude and longitude. What happens to the next phase? The ping based IP. Now this is just a basic date and time for you to understand how you can find out. This is my present real time. This is the date, and this is the latitude and longitude. So this is where it is trying to detect your ping book in your whole earth or global system. This is in our earth, this is where it is your ping board is actually present. So the current location of your ping board is this using your gigabit Ethernet. So that is why Ethernet is a high bandwidth peripheral which can be used. So now let us see what is the next point. After figuring out the latitude and longitude part, we are going to go with the initial estimates. The initial estimates is given as multiplication with 0.001 QNR, the storage points, and with this you are going to figure out the UKF sigma point parameters. So this is the equation of lambda, and with this WC and WM values are calculated. So the prediction is happening, and let us see what is the output. We are predicting the sigma points, the mean points, the covariance points, and measurement prediction. So yes, This is the UKF estimate with your noisy GPS data. So covariance, measurement prediction, cross covariance, and the storage of your GPS, EKF and UKF. So this is how both the 3D planetary system, this is how the 3D planetary system and EKF and UKF. So for IP based latitude and longitude, you are going to figure out what is the how these both are connected interdependently. So thank you everyone. We will discuss the next AI implementation in your Ping. Thank you.